Hello and welcome to Sage 100 User-Defined Scripting Basics. Today I'll be going over applications for user-defined scripts in Sage 100 with specific examples. First, what are user-defined scripts? User-defined scripts are small bits of custom code that use the VB script custom programming language. Scripts are limited in scope, but they typically execute in a single location to perform a specific action or task, as opposed to custom programs or extended solutions, which can act as entirely new tasks within Sage, including some add-on modules. That said, while individual scripts do specific things, scripts can be used in a wide variety of ways to accomplish tasks otherwise not possible through out-of-box functionality. Throughout the course of this presentation, I'll give specific examples of various things that can be accomplished using user-defined scripts. When you approach any potential challenge in software applications and with the prospect of customizing your software, it's important first to ask what exactly you need and to ensure that you're choosing the right tool for the job. So asking questions like what you're trying to accomplish, if a standard function that you might not be aware of can achieve the potential end result. Can the information you're looking for be gathered in a report or a view, or is it actually a custom trigger or some sort of write back that you're looking for? It's also important to consider how often you need the function or application, as that can also influence things like how much you're willing to budget to develop a custom tool, or if you need a custom program entirely for this application. Before I get into scripts themselves, I want to talk a little bit about other custom reporting tools that could possibly get information, as sometimes when companies or users are looking for custom solutions, what they actually need is a better way to gather data out of the system using reporting. There are two main ways we can do that in Sage. The first is with a custom crystal report. All the graphical forms in Sage are crystal reports, and we can also design custom ones using the Sage data tables. Strengths of crystal reports: they're powerful and customizable ways to compare data and display the results in an easy to understand fashion. You can compare data from multiple tables rather than only two, as is the case with MS queries. You can use a variety of selection criteria to select specific sets of data, and you can have those selection criteria either built into the report or chosen at runtime. And you can group the information in a dynamic and, again, easy to parse way. Limitations, though, it's only useful for output of data, so we can't interact with the data in any way. We can only look at it unless we export it to possibly to something like Excel. It can be time consuming to design, and likewise, with time as a factor, reports can also take a long time to run based on the size of the data set and the complexity of the query. The other thing to consider is that crystal reports, if they're not explicitly designed to be exported to Excel, sometimes do not do so in an easy to read or clean way. Another option for reporting, Business Insights Explorer, which is a built-in application in Sage 100 that can gather data from various data tables within Sage. A relatively quick and simple way to output a list of records from a particular table. Easily editable, you can add and remove fields from BIE views, and likewise can filter those views based on selection criteria that you specify. Those views can then be saved as settings to use and rerun later. And it can also be exported easily into Excel and other formats, as these are displayed as discrete grids. However, a lot of the things that are good about crystal reports, Business Insights Explorer cannot accomplish. It has hard limits to what data tables are accessible and which tables can be compared. For instance, in the sales order view, there's a very finite and specific list of tables that you can add into this view, mostly just the sales order in detail and the customer tables. There's no way to add additional tables like with the Crystal report. Similarly to Crystal reports, the views can be slow if the data set's very large, and they cannot readily show complex relational information between data sets. So where Crystal reports can maybe pull data from a number of tables, Business Insights Explorer is usually limited to a couple. Those are things to consider when you're thinking about custom solutions to your problem before you jump right to a custom program or a script. Now, with that said, let's get into the main topic, talking about user-defined scripts. What are they good for? Well, they can write back data to fields within Sage, something reports cannot do. They can perform calculations and then output the results either to a field or to a dialog box in a data entry task. They can write data to tables that are not even open in a current data task. So say you wanted to write back a value to an item when you made a change to it somewhere else, that's also possible. They can trigger alerts or warnings during data entry. So to warn you maybe that you need to enter a value into a specific field before you save an order or an item record, or to tell you what the total value of a field is. You can pop up dialog boxes that either just gently remind you, or also it's possible to pop up errors that prevent you from updating until you take the required action. Limitations to this functionality, and we'll talk about this more as we continue, but you need to have a clear trigger point, whether that be a field trigger or a button. Either way, there needs to be a specific place where the script knows to trigger. It can be complex to implement without interfering with existing triggers. So if you have a number of scripts that all fire in the same place, that can sometimes be complex. And also this sort of feeds into the third bullet point. It can be difficult when you're interacting with the stock actions of the business objects. And I'll talk more about business objects as I continue in this presentation, but user-defined scripts always take second priority to the built-in functionality of Sage. So if they ever would conflict with an existing action that the system will take, the system will always prioritize its stock actions first. We'll talk about that a bit more. There's two main types of scripts that we'll be talking about, and they mainly differ in the way that they are triggered. There are business object scripts, triggered scripts. They trigger off of a business object. For instance, in sales order entry, you might have a script that triggers when you go to the totals tab. So you've entered lines, the order tallies up its total, that triggers the script to fire and do whatever it's going to do. That is a business object script. They happen at a specific time. You don't see them doing anything, you just see the output of whatever they're doing. In comparison, a button script exists within the UI and is triggered when you click the button. So in this second image, the bill of materials maintenance, that calculate total button is a button that triggers a script that tells it to tally up the quantity per bill of all the items. We'll talk a little bit about different script triggers for business object scripts, as they tend to be more diverse field of scripts. All business object scripts are attached to a particular table and they trigger under specific conditions. So if you want to have a script that checks for a field value during sales order entry, you would attach it probably to the sales order header, and you would say, pre-write, pre-total. I'll get into that in a moment here, but you would tell it at that point on this table to trigger. In some cases, you might want a script to trigger at multiple points. Depending on things like, where you're entering data, you might want it to recheck after something has been changed. And so you would assign the same script to trigger multiple times at different points. So you see in this example image, the same script is set to trigger off post validate on 3 different fields. And then again, this one is set to trigger on 5 different fields. So we really want to make sure that this particular script is triggering. Scripts are also given priority to ensure that they don't all try to trigger at the same time. The priority number is the time in milliseconds that the script waits after a trigger before executing. In this case, these scripts are all triggering at different points, so they all have the same priority. But if I had, say, a post-validate script to trigger off of this item code field, and then I had another script that also needed to trigger post-validate off item code, I would need to give them different priorities to make sure that they didn't both try to run at the same time, because more likely than not, neither of them would trigger. So let's talk about column post-validate and what that means. So a script set to column post-validate triggers after a value has been entered into a particular field. So in the user interface, we click into a field to enter a value, say again, this script is looking at the item code. So I put in the item code, and then that script, this particular script, which I will show as an example later, pulls a value for color from the item code record. And so after I enter the item code, the script knows to go and get that value and then write it back to the line. And that's mainly what this is useful for. So if you want the script to do something based off a value in a field, or you want it to check whether the value of the field is valid based on some criteria, that's a post-validate type of situation. So, a script that checks a field value against a list of values to see if it's valid, calculating a derived value based off of a number entered into a field, price, quantity, that sort of thing, or copying a value entered in a field into another field on a different table. Usually that would happen if you had maybe a user-defined table that was gathering up records to store as a sort of historical record. In that case, you might have something like that. Table pre-write. So this is a trigger for scripts before a record is saved to the data table. So typically the most common instance of this, if you were in, say, sales order maintenance, or sales order entry rather, or item maintenance, when you hit that accept button, that is the point where the business object goes to write the record to the data table. So table pre-writes would trigger at that point. A script that checks to see if a field is blank or not, you might have that be a pre-write. So if you wanted to have a field be required, but you had issues with just using the required field, advanced field setting in Sage, you might set a script to do it instead, to get around things like not having it trigger when an RMA is created. That's the most common scenario where this is relevant. Or a script that writes a record back to the detail based on whether it already exists or not. You might have a surcharge that you need to add to all orders, and you don't want to have to enter it every time. So rather than do that, you have a script that at pre-write just adds the line to your order. And I have an example of that I will show later on in this presentation. Table pre-totals. Now, this is sort of similar to pre-write, only this is an even earlier point in the process. So in orders, any sort of data entry task where there are lines and then there is a total tab, if you enter lines or change the order lines in some way and then tab over to the totals tab, that will trigger a table pre-total script. Useful for scripts that are checking line information, sales orders, purchase orders, bill of materials even, and then trigger based off that. A script that calculates total from a field and outputs to a header field. So say you had a user-defined field that was a numeric value on each of your lines, and you wanted to output the total of those numeric values to a header field, like any of the other totals that you might have on an order, you could do that as a pre-total. So as you went to the totals tab, it would add up all those values and then put them into a UDF on the header. Or a script that checks for a particular line item and then displays a warning if that line item's not on your order. You could also trigger that pre-totals instead of pre-write, have it happen a little bit earlier, maybe just a gentle reminder, not a hard error. So now that we've talked about business object scripts that are triggered off the business object, we can talk about button scripts. Essentially, most anything that a business object script can do, a button script can also do. The other thing that button scripts can do that business object scripts are not usually great at doing is it can launch other tasks from within entry. So for instance, say I wanted to have a button that not just opened item maintenance, but opened item maintenance to the item that I had just come from. There are a few different ways you can do that, and that's sort of a general example, but you could also have a button script that did that. That maybe pulled up this bill numbers item record as a button. Button scripts are also useful if you have some sort of logic that you want to perform, but you maybe don't always want to do it, and whether or not you want it to happen or not is really just a human logic decision and not a clear black and white situation, as is the case of this calculate total. That's there as a sort of informational helper tool. It doesn't need to happen all the time, and I don't want it to constantly be happening as I'm going to accept my bill of materials. So I have created a button that just lets me choose when I have it happen. And that is a good example of the way that a button script can be useful, where a business object script might be intrusive. So now that we've talked about all the things that scripts can do, it might be useful to also talk about things that scripts cannot do or limitations to them. Generally speaking, you can't trigger a script from outside of a Sage task, at least in the scope of the scripts that we're talking about here. So what does that mean? It means that we can't have a script that just happens, from printing or during a register update. That's not really a space where we can set a trigger point. As we've gone over, the business object acting is what usually gives our scripts the cue that they need to trigger. So off of a pre-write, a pre-total, validating on a field, none of those handholds exist if we're outside of the user interface, and so we can't really trigger a script from there. And as I mentioned earlier, Sage always prioritizes its own built-in logic and processes, and scripts are using those business objects to execute. So if the script ever tries to do something at the exact same moment that Sage itself is just trying to do something, and this is sort of similar to the priority that we set if we have two scripts trying to trigger at the same time because they'll conflict. Well, that can also happen if a script overlaps with something that Sage itself is trying to do, and Sage will just ignore the script in that circumstance most of the time. On some occasions, it'll actually error out instead. And that's the other thing that I sort of an image here for. If a script encounters an invalid field value, if it tries to perform an illegal action, the most common being if it tries to divide by 0 in some sort of a calculation, it'll output an error, and that can also be a problem when a script is triggering. So that brings me to my next point, always thoroughly testing a script before deploying it live, trying to break that script in a test environment. Of course, I or anyone designing a script for you will test the script before even bringing it to you to deploy into test, but it's always important for end users to test through scenarios is they might think of something, or they might use the software in a way that I or another technician might not, because we're not end users. So the way that we interact with the software is a little bit different. It's also just good to have multiple people test a piece of script to make sure that there's nothing that could trigger some sort of error down the road, so we can avoid complications. On the same score, if you're upgrading your Sage 100 to a newer version, it's important in that new version, while it's still in the testing process, that you make sure that scripts from the old system work in the new system as well. Occasionally, Sage will add fields or change the way that business objects behave slightly, and that can sometimes require adjustments to a script to ensure that it does not encounter any errors. Now that we've discussed in hypotheticals the different ways scripts can be used and the different places we can use them, I'm going to go over some specific examples of scripts to sort of give you an idea of how these things might be deployed in real world situations. The first, in purchase order entry, I have set up a script on the header to trigger and check the totals of this particular order. So I'm going to go in here, and we're going to go in, and so look here, and here's our items. I'm going to change the extension because this is a pre-total script, so I want to make sure that it triggers. So let's just set this to $10. We're going to set this to $10. Now I have 20. I'm going to go in here. I'm going to hit accept. Popped up on the wrong screen, but here, as you can see, it says please check ordered totals on the lines. So it's just telling me pre-write, make sure that the order totals for this purchase order are correct. So just to sort of, this is what I was talking about earlier, the difference between a warning and an error. This isn't stopping me from saving the record. It's just saying, hey, maybe go back and double check this. You might want this sort of a thing to just remind people to check for things. The next script I'd like to look at, making a field required or validating an entry in a field. We're going to look at sales order entry. Now, I talked about this before. Sometimes you want to have a field be required for data entry, but adding a hard requirement for a field through custom office through advanced field properties can be problematic, especially in sales order entry, because if you try to generate an RMA and the field value is blank, it'll cause the RMA to error because there's no value, but it can't ask you for the value at that point when it's generating documents. So it's possible to get around that with a script, because this particular script that I've written has an exception into it that says if the record is being written from RMA entry, don't trigger the script. So don't check to see if the value is there. In this case, we're going to check to see if the customer purchase order number has been entered. I'm going to pick a customer here, and I'm going to not enter a customer PO. Go in here. I'm going to add a line item, just one. We're going to go to the totals, and then I'm going to hit accept. And now it should stop us. As you can see, it says the customer PO number is required. So I'm going to hit OK. I'm back here. Now I have to say my customer PO number, 1, 2, 3, 4, 5, whatever. Then we're going to go back to the totals. Now I'm going to hit accept. As you can see, now it lets us go through. Now that's the sort of the second variation on what we saw before, where in purchase order entry, it just warned us about something, but it didn't stop us from saving the record. This hard stopped and said, hey, you can't proceed if the customer purchase order number is not there. Still in sales order entry now, I'm going to pull up, let's say, test 3, new sales order number, and I'm going to pull up a customer here. I'm going to hit OK. We're going to put in our customer PO number because we know that otherwise the script is going to get upset at us. So let's say I had a color field value that I wanted to write back what the color associated with a particular item is. I'm going to let's scroll over here and we can see here's our color. I'm going to drag this over so that it's a little bit easier to see back towards the item code. So this is an item, comes in different colors, let's say, and I want to output onto the grid what the color is so that people enter, my employees entering orders can see that information. So I'm going to pull up my test item, which I've creatively named test. And then as you can see, it fills in the color blue. If I go into item maintenance, I'll show you that field and additional, see I've entered blue as the color. And so it's writing back blue. Note that the trigger here is a post validate on item code. So if I change the color later, the order is not going to know that. I would have to go back into the order and change it. It's just pulling that value into the order at the time that I enter it. So that's always good to keep in mind. But this can be used to pull data on items, any kind of custom attribute for an item that we wanted to output onto an order, purchase order, a sales order, an invoice, whatever. We could do that here and use a script to accomplish that. My fourth example script here, and we saw this one a little bit earlier in bill of materials maintenance, and this one is a button script. And so I wanted to, I should use my test bill. This was an actual, most of these were actual scripts that I've designed for other clients in the past. So this particular client wanted a script, a button that he could click to make sure that a bill was totaling up in quantity to 1, because for whatever reason, that was the target, was that all these components added up to 1. So this calculate total button, we hit it and it tells us the bill equals 1. This version of the script actually just outputs the total value of all the quantities. It doesn't check yes, no, it's just going to tell us the total. So if I click it again here, now we see the bill total equals 25.8. Useful for that particular client for this application, but you could do similar or math on fields and Sage for a variety of applications and reasons. Button scripts can also be used for a lot of the other things that we showed earlier, but it's, I think, most useful for calculation because it's not going to necessarily stop you. Finally, I have one more script that I want to show as an example. We do not need to save our changes. We're going to go back to sales order entry. And this is a script that a number of clients actually needed after a tax surcharge was added for delivery fees in Colorado. And we're going to go here back to SO test, and I'm going to hit OK. And as you can see, we're delivering to 80301 Boulder, Colorado. I'm going to go ahead and remove. This is the test charge that I've added into the system. I'm going to remove it so that I can just show you what it does. So when I go to the totals here, nothing changes, but if I go to accept, let's go back to that test. Go to the lines. As you can see, test charge has been added. The actual surcharge is different. This I just created for demo purposes. Adds a 60-cent surcharge item. This is a miscellaneous charge set up in common information in miscellaneous item maintenance. The script looks at the address, the shipping address for this order, it sees that it's Colorado, and then it adds this item. You could do that you could do something similar for a wide variety of reasons, based on the customer number, the ship to address, the bill to address, uh, a particular item being on the order needs to be accompanied by another item, say. You could do that too. You could have a script that looped through the lines, checked for that item, and if it found it, added this second item. A lot of different applications for this sort of functionality. And that concludes my presentation. Thank you for watching. And if you have any questions, you can find our contact information at our website, v-bcc.com. And thanks for watching.